Hi everyone, this is Adam again. So this is the chapter on enlargements. So hopefully it won't be too bad, kind of axes of symmetry, these sort of things, and how you calculate it out. And yeah, that's kind of it. So not too much to this chapter. Hopefully be done fairly fast, so it should be a short video, hopefully anyways. And then yeah, I'll go from there. So first of all, the different types of kind of transformations is you can have a translation. A translation, basically, you can probably guess from the word, is that you keep everything the same, but you just kind of move it. So it's just basically you move it, it's down here. So it's the exact same. Everything are the same length. So if this was 3, this was 4, this was 5, it's also 3, 4, and 5. So you just move it around the place. So that's called a translation. You have axial symmetry, which is basically when you have your x and your y axis, and let's say you put maybe the letter F here. Okay, so I might actually do this as best I can. Like here, and let's say I want to do the letter F. Like this. And I want to do axial symmetry like this. What does it turn into? The way you do it is you get this, you look at the different points and you just bring them over. So 1, 2, 3, 4, then you do another 4. So 1, 2, 3, 4. So that point goes there. So the F kind of goes here and the back line is here. And then it goes over 3, down a half, back over, down, over 1, and down. So basically, this point was 2 over, and therefore it goes 2 over. This point is 3 over, and therefore it goes 3 over. This point here is 5 over, and there it goes 5 over. And so on and so on. So basically, you measure the distance to the axis, and then you just go the other side the same distance for each of the points. Okay? So that's axial symmetry with the y-axis. So if you flip it across the y-axis, then if you flip across the x-axis, what happens? So now you do the same thing. You say, well, this will go down 1. This is 1, so therefore it goes down 1. So the bottom's there. It goes up like that, goes across, there, 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 and there. So basically now what you're doing is that all above it, and so on and so on. So as long as you keep the distances the same, everything is fine. Okay? Finally, what about, so I'll do something a little bit easier for myself to show what central symmetry is. So if we just have our axis like this, and let's say we do, okay, no, let me just, as best I can. Okay, so I'm just going to grab a ruler really quick. So here, with a central symmetry, basically instead of flipping it on an axis, you flip it through the center. So let's say we have some shape like this. So there's 4 distinct points. So what you do is, I'm going to do them in different colors now. So you grab this point, you put your ruler down, and you flip it through the center. Okay? So it goes there. You do the same for this one. So you just go through, like so, go through the center. That'll end up here. Do the same for this one. Yeah, so it should be here. Wait, sorry, what am I? Sorry, just 1 second. I'm just going to think about this for a second. Because I should get... Yeah, sorry, that should have went down here. Sorry, that was my fault. I kind of went off a small bit. It should have went there. And then you can probably believe me, the very last one goes up there. So that would be this one. Goes to there. So basically, the axial symmetry, you only went across one axis, one or the other, whereas this, you go across the center point, and that's it. So if you did two different axial symmetries, you end up with center symmetry. So center symmetry is just through a point, or in this case, it's the same as two axial symmetry. So an x and a y, or a y and an x. Okay? All right, the next thing to look at is scale factor center of enlargement, which is something like this. So basically, let me just get my ruler again. I'll just get a nicer one because I will be doing a lot more calculations. So for this one, basically what you have is they say, okay, so here's your center of enlargement. Okay. Here is your object. So just a simple triangle. And the scale factor is 2. Okay. So what does that mean? That basically means that you get the point. So say this point. You'll measure, you'll say, okay, how far is it from this? You'd say, okay, it's 4. And you want to, whatever that number is, you multiply it by k, so in this case 8. And now you put a point that's 8 away. Okay? And that's it. Okay? Now for this point, you'll say, what is this? It's 4 over and 3 up. So you will draw a line. So instead of going 4 over, you will go 8 over and then 6 up, going through that point. And you will get this point here. Sorry. And then you'll do it again. And then for this one, it's over 6 and up 2. So now if we're going to do it, you go over 6 and up 2, you would get this point. So again, you're always going through this, where the lengths are simply doubling. So your new object is this one. So if this length is x, this length is also x. If this length is L, this is also L. So again, they'll ask you to do this on your page, basically, and you'll just measure it out. Okay? And then you'll just multiply it by whatever k is. So in this case, your scale of enlargement or scale factor is 2 because you've doubled it. Okay? And also if this is A, B, and C, so points A, B, and C, this is A prime, B prime, C prime. So this is the image. And then this is the actual object. Okay? Another voice crack. But that's how you do it. Okay? All right. And now with the enlargements basically, so what you have is, so let's say I tell you that this is one object. This is a bigger version of it. And it's 11, 12, 4, 15.4, 16.8, and then 5.6. Basically, your scale factor you can figure out. So K is basically, so this is the image again. So obviously, this side corresponds to this side. This side corresponds to this side. And then the white side corresponds to the white side. So the scale factor K is always the image side divided by the actual side. So it's 15.4 divided by 11. Or it's 16.8 divided by 12. So the purple divided by the purple. Or it's 5.6 divided by 4. But regardless, you'll get 1.4 every single time. So your scale factor is 1.4. Okay? So these are also similar triangles. Okay, so just to remember, they're similar triangles. Because it's an enlargement, all you're doing is getting the size different. So all the angles stay the same. So this angle is this angle. This angle is this angle. And this angle is this angle. So everything that we did about similar triangles in the last video in geometry is still applicable. Okay, so the next thing is, if I told you the area of the object is 2, and I said K is equal to 4, what's the area of the image? So your scale factor is 4, so it's getting 4 times bigger, so the lengths are increasing by 4. So what do you think happens to the area? The answer is 8. No, it's not. It's not 8. What you do is you get your area and you multiply it by K squared. Because remember, what is area? Area is length by width. So what happened? If K is 4, what does that mean? That means your length gets 4 times bigger and your width gets 4 times bigger. So you have to multiply the 4 twice. Okay? So what you're basically doing is the length by width, you know, is equal to 2. But now you're doing 4 times the length times 4 times the width. So now it's going to be 16 times the length by the width. This is 2. So it's actually 32 units squared. Okay? All right. I'll do one of these questions and then I think I'll leave it there for enlargement. So again, it's quite a short chapter. There isn't much to do. Okay. So here you have your origin of enlargement. You have one triangle here. Where this is a right angle. You have a bigger triangle here. So let's say we go from here. Okay, so again, if this is C, A, and B, this is A prime, B prime, and C prime. So now you're told that this is x plus 1, this is x, and this side is x minus 1. You're told, okay, well, sorry, first of all it says find the value of x if this is a right angle. So remember, these two triangles are similar, so the angles are the same. So if this is a right angle, this has to be a right angle, okay? So now, you might be able to guess what x is. The answer is 4. It's again a 3, 4, 5 triangle. So that's one thing to know, that like the 3, 4, 5 triangles, they come up so often. So it's one of those things that's nearly worth knowing. But let's do it out anyways. So x plus 1 squared is equal to x minus 1 squared plus x squared. So x squared plus 2x plus 1 is equal to x squared plus x squared minus 2x plus 1. So the plus 1 cancels. The x squareds cancel. So I'm left with 2x equals x squared minus 2x. So x squared is equal to 4x. So either x equals 0 or x equals 4. Clearly x equals 4. Because if it was 0, then you're saying that it's 1, 0, and minus 1. Okay? And that's obviously not true. So it's 4, 3, and 5. And then it says the scale factor is 5/4. So k equals 5/4. Find the lengths of B. So find the lengths of the original triangle. Okay. So k is equal to 5/4. So basically, these lengths. So if I say A, B, and C, when you multiply them by 5/4, you get the corresponding sides. So A times 5/4 gives me 5, and therefore A has to be 4. B times 5/4 gives me 4, so B is going to be 16/5, that's 3.2. C multiplied by 5/4 is going to be 3, so C is going to be 2.4. Okay? So that's then the lengths of the smaller triangle. Okay? So here the scale factor was 5/4, but that's when this is the image and this is the object. But if we decided to call this the image and this the object, then our scale factor k would be equal to 4/5. So if you want to go from here to here, your scale factor is 5/4. But if you want to go from here to here, then your scale factor is just 4/5. Okay? So not too bad, I'd hope. Enlargements are quite a nice chapter. Like if they come up, you're typically quite happy. All right, I think I'll leave it there for today. So all that's left to go over is just the coordinate geometry of the line, which is a good bit more complicated than junior cert, and then coordinate geometry on the circle, which I would say is quite hard. So there's probably 2 more chapters, 2 more videos hopefully, and then that'll be the Leaving Cert course done. So yeah, thanks very much for tuning in, and I think I'll let you off. So thanks very much. I'll see you next one.